All right, so let's talk about waves real quick. We're going to start by talking about some of the different variables and some of the different behaviors of waves. And the first thing that I'm going to do is I'm going to represent a wave on a graph. And this graph that I'm going to represent the height of the wave on the y-axis, and then the time that passes on the x-axis. So basically what this means is that we have a wave that's going up and down and up and down and up and down. So there's a wave, but remember that this is a distance versus time graph. So this isn't showing us the actual, like a picture of the wave. This is showing us what's happening at a single spot. So if we were at the ocean, this is like measuring a surfer's position as they go up and down and up and down, because this is a position versus time graph. So from this graph, we can pull some useful information. One of the key pieces of information that we can pull is we can pull right here the period of the oscillation. Basically, how long it takes for it to repeat a complete wave. So the period could be measured a couple different ways. You could measure it from here to here, where you can see that that's one full wave. But it's actually probably best to measure it right here, and this is how I probably should have drawn it. If you measure it from crest to crest, you'll never make a mistake by accidentally not getting an entire wave. Um, Often, if you do it from the middle to the middle, like I drew here, students will sometimes, because they're in a rush, make the mistake and only measure half of a wave. So don't want you to do that. Measure your periods from crest to crest. So that would tell us, okay, it's taking uh, 30 seconds between waves, or it's a minute between waves. It tells us how long each wave takes. So period is measured with the variable t, because obviously period starts with a t, and that's how long a wave is. But closely related to that is 1 over f, which is the frequency. So really often when we talk about waves, we don't talk about period, we talk about frequency instead. So to get the frequency, you just take 1 over the period. So given a graph like this, you could very easily figure out the period and the frequency. The other type of wave that exists is called a snapshot graph. This is what would happen if you like froze the wave in the moment and graphed the point, or the height and the horizontal displacement of every single thing. So the graph is going to look really similar. We still have blah, 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 blah. Okay, my wave drawings aren't great. But it still kind of like has the same look, but it's giving us different information. It's not telling us what's happening with the wave over time. We have no idea if this wave is moving quickly or slowly or what it's doing. We just have a snapshot that just tells us, relatively speaking, how long the waves are. And so the important information that we can get from this graph is we can figure out the wavelength. And wavelength, again, your best call is to measure from crest to crest. And that's just like, this is how long a wave is. So maybe it's 50 meters between waves, or maybe it's an inch between waves, depending on the type of wave we're dealing with. We'll have different wavelengths. So using the snapshot graph, you can get wavelength. Using this one that's called a history graph, you get period. There's one other piece of information that's actually available on both graphs, and that is the amplitude. That's how high, if it was like an ocean wave, that's how high and how low it goes. And amplitude is always measured from the equilibrium position up or from the equilibrium position down. So amplitude is either up to the crest or down to the trough. Be careful that you don't make the mistake and measure it from trough all the way up to crest. That's not an amplitude, that's double the amplitude. So we can measure the same thing on the snapshot graph. And amplitude is not always a super helpful value. It doesn't actually show up in very many of the calculations that you'll see, but the most important thing to know about amplitude is it does tell us how intense the wave is. So obviously a bigger ocean wave would have a bigger amplitude. A sound wave with a really high amplitude is one that's really loud. An earthquake with really high amplitude would be one that's very destructive. A very high amplitude light wave would be very, very bright. So if you think about amplitude as always being related to the intensity of whatever wave, it'll give you that information. There's one other key piece of information that neither of these two graphs can give us alone, though. and that is the information about the actual speed of the wave, how fast the wave is moving through time. The reason why neither of these graphs can tell us that information is because the history graph does have a time stuff, but it has time stuff related to the wave going up and down. While we do know how long it takes to go up and down, we don't know anything about how far over it went during that time. The snapshot graph, on the other hand, gives us the information of how far over a wave goes, but it doesn't tell us how long it takes for that to happen. So you actually need both the history graph and the snapshot graph in order to figure out the wave speed. Or it could be just told to you, or it could be something that you observe. And often, wave speed comes down to a very simple calculation of just looking at how far it travels over how much time. And that's going all the way back to kinematics, displacement over time. So wave speed, or the velocity of the graph, you'll see that, or of the wave, you'll see both of those terms kind of talked about, wave speed or wave velocity. You have to be careful not to confuse those two terms, because a wave actually moves in two different ways. The first type of movement of a wave is the oscillation, and then the other type of movement is how it moves through space. But when it's moving through space, it's only moving one thing. It's moving energy. If you think about an ocean wave isn't really moving matter. The water itself, say like when you drop a rock into a pond, the water that like splashed when you hit it with the rock doesn't end up on the far shore. The energy from that gets all the way to the far shore, but the water stays basically in the same spot. The same thing is true of like sound. When I talk, you're not hearing, my air isn't getting to you, hopefully. That's kind of gross. And we can even prove that that's not happening because you're hearing me through a computer right now. So obviously it's not the air that's being carried to you, it's the energy of the wave that travels from me to the microphone. Then electricity magic happens. Then it gets to your computer, and when it comes out of your computer, there's a little speaker that vibrates a little bit, and it's not producing air. It's just vibrating the air, and the air from your computer doesn't get to your ear. Just the energy translates. So a wave moves energy. It only oscillates matter. So when we're looking at waves and we're talking about the wave speed, we're not talking about how fast it's moving the material. We're talking about how fast the energy moves. There is another thing that's often related to the waves, and they often talk about the particles' average speed. Average speed. If we're talking about the particle's average speed, we're not looking at how fast the wave is moving. We're talking about how fast a particle is moving, like up and down on average as the wave passes. So make sure that you have the separation in your mind of the wave speed, which is what the energy is doing, and the average speed of the particle, which has to do more with the oscillations that tend to go up and down if we're talking about a transverse wave. So those are the key ideas for wave properties. Make sure you have the difference between the two graphs sorted out. You know all of those variables specifically. Just to go down the list one more time, make sure you know what period is, you know what frequency is, you know what wavelength is, you know what wave speed is, and you know what particles average speed is. And if you got all of that stuff out of this video, oh, last one, you know what amplitude is. And if you got all of that stuff out of this video, then you are in good shape. Thank you so much for watching.